Welcome to a lesson with Dr. Powell. Let's take a look at exponential functions and logarithms. For instance, what if we have 2 to the x, an exponential function? Its inverse, if we had y equal to it, it would be a function. Now, its inverse is something that'll undo what this does. So what this does is it takes x and as an input, and it outputs 2 to the x. Its inverse will work backwards to give you x again. So precisely, we're going to use the notation log and say base 2. And this is a function with an input right here. And this is going to represent the inverse of, say, 2 to something. So these are two ideas will be inverses to each other, meaning that if you do log base 2 and then you put 2 to something in here, like 5, then that should be 5. Or if you have 2 to the, and then you put log base 2 inside of this, so that means first you do this function. Suppose we do maybe like a 3 this time. Do this function, then you do that function, you'll end up getting 3 back. So they'll invert and undo each other if you do one function and then you take the output of that function and put it into the other one. Well, this provides a nice handy way of thinking about what logarithms are. They're exponent extractors. You see how this log base 2 of this, it extracts the exponent for 2. So if I put in any number at all, like log base 2 of 32, say, then basically what I'm doing is I'm thinking, hey, wait a minute, this is really 2 to something. What is that something? That's what it's equal to. So, and in this case, it's 5. It's a lot like maybe like a square root type deal, where log base 2 is 2 answers a question, just like square root answers a question. Namely, square root answers the question something like this: what times itself is equal to that? Just like here, we're saying 2 raised to what is equal to that. So it's pretty much just another idea that we can use when we're thinking about things, and it undoes an operation. Just like square root undoes squaring, this right here undoes taking a base and raising it to something. So for instance, log base 2 of 1 over 4. Well, if we first rewrite this as 2 to the negative 2, then we know that this is equal to negative 2. We could do that in sequence. We could rewrite 4 as 2 squared and then 1, and then rewrite that as 2 to the negative 2. That would be fine. And then we'd end up seeing that. So that's a nice handy way of thinking about logarithms. Thanks for watching.